Welcome back for section B of June 2024, Unit 2. So the first question is, this question is about the reactions of halogenoalkanes. When halogenoalkanes are heated with potassium hydroxide, the products depend on the condition. Okay, state what condition other than suitable temperature and concentration of potassium hydroxide would give a high yield of butanediene and butadiene. To get butanediene and butadiene, we need to add ethanolic potassium hydroxide. I mean, like the hydroxide. If you add it in terms of ethanol, then they will be producing alkenes. Give the type of the reaction occurring in A1. This is an elimination reaction. Elimination reaction. Why elimination reaction? Because from chlorobutane, chlorine is going to be eliminated along with two of the hydrogens, producing alkene along with water. Okay. State what conditions other than suitable temperature and concentration of potassium hydroxide would give a high yield of butanol. Now, if you want to produce alcohol, then we need to add this potassium hydroxide in aqueous condition. Aqueous potassium hydroxide. Complete the mechanism for the reaction of potassium hydroxide with 1-chlorobutane to form butanol. Use the curly arrows and relevant dipoles. Okay, so this is going to be del negative. This carbon is del positive. We will have a lone pair here. So this will attack this carbon, and this one is going to go over here. Okay, my bad. This one is going to go over here. Okay, and next we will have this. We give two reasons why under the conditions used in B2, the reaction between potassium hydroxide and 2-iodomethylpropane is faster than reaction between potassium hydroxide and 1-chloro. Okay, so this compound that you see, this is a tertiary halogenoalkane. So we will write down that tertiary halogenoalkane are more reactive than primary halogenoalkane. And also you see this over here, CCl bond is going to be broken, and over here, Ci bond is going to be broken. And according to the bond enthalpy, Ci bond is weaker than CCl. That's why the 2-iodo-2-methyl propane is going to be much more faster in chemical reaction compared to 1-chloro butane. Next, we have question number 17. In a titration reaction between a weak acid and weak base, indicators do not give a distinct color change. So other techniques must be used. One other technique is thermometric titration. So I have given the procedure. What do? We first take a temperature of 30 cm cube of dilute ethanoic acid and put it in a polystyrene cup, and then ammonia solution of concentration 1.30 is added in the portion of 5 cm cube. For the simplicity, I have already drawn the two crosses, and the students actually plotted the graph over here, right? Next, find the end point volume and maximum temperature by adding appropriate lines of best fit to the graph, right? So they are telling you to write this one. So that I have already done. Now the end points volume is going to be straight this one. Which is going to be about something about 21 cm cube here. So endpoint volume is 21 cm cube, 21 or 21.5, you can give it. Maximum temperature rise. So the maximum temperature rise is going to be this. Which comes as 27.5 27.5 degrees Celsius, right? Calculate the number of moles of ammonia added at the endpoint. So you see, we have added 21 cm cube and the concentration of ammonia was 1.30. So let's calculate the moles. The mole is going to be 21 times 1.30 over 1000, which is going to be equal to 21 times 1.30 over, which gives us 0.0273. Okay, 0.0273 more. All right. This question, the reaction that occurs is shown. Okay, this is the reaction that occurs. Calculate the enthalpy change of neutralization for this reaction in kilojoule per mole. Give your answers in appropriate number of significant figures. Okay, so first of all, you see the density is already given 1 gram per cm cube. We need to first find the mass, right? So mass is, we have added 21 cm cube in how much? We have added 21 cm cube in 30 cm cube of ethanoic acid. 30 cm cube of ethanoic acid. So the total mass is going to be 30 plus 21, which is 51 gram. Since it is gram per cm cube, we can directly convert cm cube into gram. And then energy released is actually Q equals to mc del theta. Now mass is 51 gram times 4.18 times change in temperature. So what was the initial temperature over here? The initial temperature was something around 20.7, something around 20.7. And the final temperature we got was 27.6. So 27.5 minus 20.7, that is going to give us our answer, which is equivalent to, let's try and find that out, 51 times 4.18 times 27.5 minus 20.7, which is equal to 1449. Okay, now let's just do it in my calculator. It comes as 1470.9 joules. This is the amount of energy in joules, right? Okay. If that is the case, then we have to find the enthalpy change. Del H is energy 1470.9 over moles. Moles was 0.0273 times 1 over 1000, just to get the value in, kilojoule per mole. And the answer is minus 54 kilojoules per mole. We need to include a sign. You see, include a sign. Most of the students forget about this sign. This is an exothermic reaction, so we need to give a negative because the temperature was increased. Next, question number 18. Chlorine dioxide, ClO, can be used to treat water to make it safe for drinking. The molecule is a free radical. One suggested structure is shown. Complete the structure using dot and cross. Okay, we need to use dots for oxygen and crosses for chlorine. Now, the free radical is on top of chlorine. To make that happen, we need to have an unpaired electron on chlorine, right? So here we have a double bond, so we can with cross, and dot. Okay, another dot, and then we can give another dot here, here. So we have all of the electrons here, and then we need to give a single bond here. And the single bonds, this is going to be the equivalent bond. Now, if I have already used up four chlorine electrons, then I need to give three more here, right? So you see this is paired, but this one is unpaired. And due to that, we have a free radical on top of chlorine, right? Give a reason why chlorine dioxide is not a linear molecule. This is not a linear molecule because you see there is a lone pair in chlorine over here, right? So we will write down that lone pair of electron repels the bonded pair electrons. So due to this repulsion, this is not a linear molecule. It kind of like gets bended towards inside. Next, chlorine dioxide can be made from potassium chlorate 5 in a two-step process. First, potassium chlorate reacts with concentrated sulfuric acid to form compound A. Compound A then undergoes a disproportionation reaction to form chlorine dioxide and hydrogen chlorate 7. Okay, state the meaning of Roman numerals in chlorate 7. Okay, uh, this Roman numerals actually gives us the oxidation number of chlorine if it were an ionic substance, right? So we can write down that in chlorate 7, chlorine as +5 charge, and the same thing in chlorate 7, chlorine as this is +7 charge. State the oxidation number of chlorine in chlorine dioxide. Now, to calculate the oxidation number of chlorine dioxide, we need to write down. Let's do it over here. So ClO2. If I make this one as X plus, we know oxygen is -2. We have two oxygens, and this is a neutral. So this is 0. So if we subtract X will be equals to +4 over here, right? So the oxidation number of chlorine is +4. We can directly give it as +4. Now in step 2, compound A undergoes disproportionation reaction. Deduce the possible range of oxidation numbers for the chlorine in compound A. Justify your answer. Okay. Now both of them are between oxidation number between +5. Oh no, my bad, sorry. It will be between actually +4 to +7. Why? Because we're talking about chlorine dioxide and chlorate 7. And in chlorine dioxide, the oxidation number is +4. So the answer number has to be between +4 to +7. So likely the value will be +5 or +6, right? Within that. Now, compound A has MR 84.5. Decomposition by mass of hydrogen, chlorine is given, and the remainder is oxygen. So let's find out the remainder of oxygen. Oxygen is going to be 100 minus 42.01 minus 1.18. If we plug in the values in the calculator, we get a value of 56.81. Now, if we do the empirical formula method, we have H and then Cl and then O. H is 1.18, Cl is 42.01, and oxygen is 56.81. We need to find the moles. So 1.18 over 1, 42.01 over 35.5, and 56.81 over 16. We get 1.18 over here. If we plug in this one in calculator, we get a value of 1.1834, so 1.18. And for oxygen, we get a value of 3.55. So the smallest is 1.18. So 1.18 divided by 1.18 and divided by 1.1. We get 1 is to 1 is to. This is going to be 3. So empirical formula is HClO3. They want us to find the molecular formula. So to find that, we need to find an N. Now N is molecular mass over empirical mass, right? So molecular mass is already given, which is 84.5. Empirical mass is 1 plus 35.5 plus 16 times 3. You will see that this becomes 1. If this one is 1, that means HClO3, 1, which remains as HClO3. This is my compound. Write an equation for each of the two steps in the formation of chlorine dioxide using your answer to be state symbols are not required. In the first step, we need to react potassium chlorate as written in the question paper, KClO3, along with sulfuric acid, H2SO4, right? Now this will give us HClO3 along with potassium sulfate, K2SO4. Now we need to balance. To balance, we need to put a 2 over here and then a 2 over here. This is the first step. And then for the second step, we will take this HClO3 and then this actually decomposes to give us ClO2 along with HClO4, which is stated in the question paper, along with H2O. To balance, I need to put a 3 over here and a 2 over here. Now this one is balanced. In question number 19, we see one industrial preparation of ethanol is by catalyzed hydration of ethene via reversible reaction. We see a reversible reaction happening over here. Identify the name or formula of the catalyst used. We use phosphoric acid as a catalyst. Phosphoric acid as a catalyst. Under this condition, the conversion of ethene to ethanol is 5%. The conversion rate is very low, but the overall yield is 95%. How do we increase the overall yield? Suggest what happens to the universal equilibrium mixture containing ethanol so that the overall yield becomes this. So first of all, what do? We condense vapors of ethanol so that we get more ethanol. And second, we recycle unreacted reactants. By doing that, we can actually increase the yield of ethanol. The temperature used is 300 degrees Celsius and pressure used is 7 megapascals. These and the amount of water present in the mixture, reaction mixtures are all compromises. Explain why the temperature used is a compromise. You see, the forward reaction over here is exothermic. That means if we lower the temperature, equilibrium shifts to the forward side and the yield is going to increase, right? This is the compromise because enthalpy change is exothermic. It favors low temperature. 300 degrees Celsius is a compromise to increase the rate of reaction. Rate of reaction. Because we want to get a fair amount of ethanol from these mixtures very fast, right? Explain why a manufacturer might suggest a pressure of greater than 70 kilopascal because it favors high yield of ethanol because more particles in reactant side than product side. Why is this? Because you see in the equation, there is only one and there is only two. We have one particle, we have two. If I increase the pressure, equilibrium will shift to the forward side, producing more ethanol. So if we increase the pressure, more ethanol is going to be produced. So that's why the manufacturer wants it to be greater than 7 Pascal. At pressures greater than 7 megapascal, a waxy solid forms, which melts over a range of a temperature. Okay, since it is over a range of a temperature, we get a polymer. Now, since we are using ethene, the polymer that actually forms, or the waxy solid that is formed, is actually polyethylene. Give one other reason for not operating the process at a pressure greater than 7 megapascal. Do not include safety considerations in your answer. This is because it is uneconomical, because more, how do you call it, more containers which can withstand the pressure needs to be installed, right? So higher pressure requires special equipment to withstand the pressure. Okay. Next, increasing the amount of water in the reaction mixture without changing the pressure might also be suggested. Suggest one advantage and one disadvantage of increasing the amount of water. So one of the advantages is going to be that it will shift equilibrium to forward side, producing more ethanol, right? Now the disadvantage is the acid we used for a catalyst, it will be diluted. It will, in return, dilute the phosphoric acid catalyst. Okay. Now, the last question for section C, that there's a paragraph given. You can read out the paragraph in most cases, but if you don't have the time while solving the paper, mainly in the exam hall, I would recommend to just go for the exams because in most cases these paragraphs are not that relevant. If it is relevant, come back and then read it out. Give the IUPAC name for isoprene. So you see isoprene has 1, 2, 3, 4 carbons. So this has to be a butene. Now the naming is going to be, we have a methyl. We have a methyl in 2. So this is going to be 2-methyl but 1, 3 diene, right? Because we have two carbon-carbon double bonds in 1 and 2. Okay. Next, the peaks with the highest intensity in the mass spectrum is isoprene are at M by Z 68 and M by Z 53. Identify the species responsible for the two peaks. Now, if I draw the molecular mass of this, it's going to be CH2, and then we have a CH3 as a bond, and then which is connected to a C. Then we have CH, and then we again have a CH2. I mean, like the double bond over here, and we have a double bond over here. If you calculate the molar mass, this one becomes 68. So only one of the electron is going to be lost, and we get a species like this over here. For M by Z 53, the difference between 68, the difference between 68 and 53 is actually 15. So 15 is responsible for methyl. So if I remove this methyl, then we are left with CH2 double bond, C, CH double bond, CH2, and this is going to be the charge, right? Okay, now I made a silly mistake over here. We need to write it down in this manner, C, and then CH3, because this carbon is double bonded with this carbon, not this one. Okay, so make sure you don't do that mistake. Next, the infrared spectrum of isoprene is shown. This is the infrared spectrum of isoprene. See the origins of the peaks labeled P, Q, and R. You may use a level diagram. Use the data booklet as a resource, as a source of information. You will be given your data booklet, and if you go to your data booklet, you will see that the P over here, the range of P is actually due to alkenes, pH alkenes, right? So let's just first draw it, okay, to make it more easier. So CH double bond C, we have a CH3 here, which is connected to H and double bond, right? This was our isoprene, right? Now the P is due to this one. So P, okay, they have given spaces over here. So P, it is due to CH along with alkene. So double bonded side, double bonded side. And then Q is due to this, which is, it is due to CH along with alkene beside an alkene, right? And R is due to the carbon-carbon double bond over here. We have one and we have also another one over here, right? So R, it is due to carbon-carbon double bond switching. Okay. So you just need to compare this range within your data booklet and with this range in the data booklet and this one with the data booklet, and then write down your conclusions. B, show that myrcene and limonene are terpenes by comparing the molecular and or empirical formula of. Okay, so what do we mean by terpenes? So let's go back what they said. So terpenes are made up of two or more isoprene. So it has to be twice of this, right? So if we look into the molecular formula of myrcene and limonene, of myrcene and limonene is actually 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, C10, H16, right? So we have 3 over here, 3 over here, no here. We have a 1, 2, 2 here, none here, 2 here, 1 here, and 2 here. If you count all of them, it becomes 16. 3 threes are 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Yeah, 16. But isoprene is actually C5, 1, 2, 3, 4, 5, and H8. And isoprene has molecular formula C5, H8. So you see, if we double this, we get this. So that means if we add two isoprenes, we get myrcene and limonene. That's why these are terpenes, right? Both myrcene and limonene can be completely hydrogenated by reaction by hydrogen. State the condition required for the hydrogenation of alkenes. For the hydrogenation of alkenes, we just pass over heated nickel catalyst. Nickel catalyst. And that will convert them, right? 5-gram samples of myrcene and limonene were completely hydrogenated. Calculate the volume of hydrogen required to hydrogenate each sample. Include stick symbols in your answer. Assume the volume of 1 mole of hydrogen is 24 cm cubed, right? Okay. Now 5 grams of sample. So we need to first write down the moles of myrcene and limonene found, right? Mole of myrcene is actually 5 divided by 12 times 10 plus 16, right? This is the molecular formula C4, C10, H16. So if that is the case, we get the moles as 0.0368 moles. So this is the moles, right? And mole of limonene is going to be the same because they have the same mass as well as the same molecular mass, 0.0368 mole. Now, I need to find the moles of hydrogen, as in like to find the volume. So if you see, if we talk about myrcene, how many double bonds do we have? We have 1, 2, 3. So for myrcene, ratio is 1 myrcene is to 3 hydrogens. Therefore, mole of H2 will be 3 times 0.06368, which gives us 0.1103 mole. Now, if I want to find the volume is going to be 0.1103 times 24,000. I will get the value in CMQ, 2647.2 CMQ. Now, the same thing for limonene. The ratio is 1:2. Why is it 1:2? Because there are two double bonds. So only two hydrogen moles of two hydrogen is going to react. So if the ratio is 1:2, mole of H2 is 2 times 0.0368, and we get a value of 0.0735, right? And then the volume is going to be 0.0735 times 24,000, which is equivalent to 1764.7 CMQ. Right? Let's give the IUPAC name of the product formed by complete hydrogenation of myrcene. Now you see, if we go back here, the double bonds are going to vanish. If the double bonds are vanished, the product that we are left with is just this. So we have 1, 2, 3, 4, 5, 6, 7, 8. So there are two methyls at 2 and 6. So it is going to be 2, 6 dimethyl octane. So let's write it down. 2, 6 dimethyl octane. Okay. These students were asked to carry out a single chemical test to unambiguously identify the presence of OH group in three terpenoid compounds, methanol, linalool, and citronenol. Okay. The first student uses potassium dichromate, the second student uses potassium manganate, and the third student uses potassium chloride. Criticize the students' three results, suggestions by linking the expected results, and so on and so forth, right? Okay, for the first student, the choice of first student is bad because it only identifies menthol, menthol, and citronellol as color changes from orange to green, right? Why is this? Because you see, potassium dichromate is only going to react with secondary alcohol and primary alcohol. It does not identify, or it will not react with the tertiary alcohol, right? So that's why the student will not be able to identify the OH group in all of the three compounds. What about student 2? Student two's one is also bad. The choice of second student is also bad because there are double bonds of carbon which reacts with KMnO4 and the color changes from purple to colorless, right? So basically, potassium permanganate is used. Potassium permanganate, acidified potassium permanganate is actually will going to react with linalool because they have the double bonds over here, right? And they also have a double bond over in citronellol. So they will react with this one and this one, also this one. So it does not actually justify that whether there are OH or just carbon-carbon double bonds, right? The third student choice is good. Why? Okay, so where were we? Okay, so let's just do it again. Color changes from purple to colorless. The third student choice is good because PCl5 reacts with all OH group, producing misty fume. And why is the misty fume is going to form? Misty fume is due to HCl forming, right? Because HCl, PCl5 reacts with the OH group over here, reacts with all three OH groups to produce HCl, right? So this is the paper that we did for Unit 2. If you have any questions regarding any of the parts, please leave a comment down below, and I will try to sort your problems out. And further, we will be doing some more papers like this. If you want to look into those, please do subscribe and like the video so that you can get more videos like this. Thank you so much. See you guys in the next video.